Let us start with the project where we'll be looking at the blank weight, calculating the blank weight, then we'll be moving to the material cost for the control arm or any particular component, but here we'll be using a particular part on each control arm, and this is also a sheet metal part. And then let us start with the blank weight and we'll see the scenarios how to do that. And this is the forming suite where you can see this particular suite is used for the complete sheet metal, cost estimation, progressive die, and all tooling related to sheet metals. And you can directly go to the project and go to the start menu where you can see, and you can start with the new forming analysis. And when you go to the new forming analysis, you directly can open from your chapter folder, chapter 3 material and blank weight. And here you can see a particular part known as blank weight part, and go for OK. And when you go for OK, your part will process. Here you can see the translate geometry and this many percent is complete, that message you will see, and here you will see the green progress bar. And once this is loaded, just hold for a second, and after that we'll start with our process for moving further. And once this is loaded, you could able to visualize that here and just maximize this, and here you can use this rotate button to visualize this, or you can see the close up as well. And here you can notice that lots of small holes are there, so that we need to patch it, or you can keep it also. And sometimes during the blank unfolding that may create problems, so that we have to fix it. So we'll see both the scenario without patching and with patching, how we can do that. So the first step here is to generate the skin. Here you can see the thickness of this particular sheet metal, and when you go for the blank generation or forming process, then you have to primarily extract the skin. So when you go to next, here it will show you the domain, and here you can filter also through surface. And when you go for OK, and that particular skin will be extracted here and without having any thickness. And primarily here what we do is we assign material. So whatever the material you specify, when you go to next, here you can see the domain. This is the domain which is actually defined here, domain 1, 2, 3. And if you just cancel it, you can see the domain 1, 2. If you rotate this, you can clearly see this. These edges and some edges are treated as n domain 3 this, and this collectively all this is known as the primary domain, that is my skin. And here you have bunch of materials based on your typical requirement. You can select one material. I am just selecting the CRDQ and thickness is 1.5. And if you go to the properties, here you can see the mechanical properties and forging limit diagram also you can assign, and based on that cost also, if you have a fixed or if you have a table, that also you can edit with the thickness, width and post cost as I have shown before. That also you can extract from the coil. And let me assume the default and go for OK. So just I'll cancel this because I am not updating anything, and just go to OK. And here you can see the CRDQ with the 1.5 thickness, and this is what the complete history boundaries which you can refer during your creation. And next, when you go for next, here you can see the process setup and process definition. Let us start with the process setup. And in process setup, it will show you the chord deviation, the shortest element length and maximum element size. Let me specify here 6. So it will suggest the maximum element size. You can lower this to have a better quality, better mesh, so that during unfolding it can give a high quality result. And default friction also you can see set here, or you can edit this also, friction values. So this mostly will recommend these default values. And next, when you will go for, you can see the punch direction, and if you see the punch direction, by default it will show away from the part, or you can manually set through the coordinate as well, or you can go to auto also, or if you go to the manual it will show that. So just let me go to the punch direction. Here you can see the yellow arrow which is showing the default manual configured in the G direction. Go for OK. Define the forming process. You want to create a forming or a draw, that process you have to define. I'll just go for the draw. Go for OK. And next you have to go for the solve forming. And when you go for the solve forming, you can see this. So once that is done, here you can see the typical formed part. And sometime if you look at this result, you can directly export the outline also. And if you go to the first the flat blank, here you can see the mesh outline and all this show details. It will show the independent boundaries which is considered. And once this is done, here you can see the results related to your blank, the permeability, the safety zone. And if we just go through this, here you can see the low strain areas, the wrinkle tendency, these areas, the wrinkle will be formed. Safe zone, this is the primary, the safe zone yellow areas, this green areas, and this marginal, this okay, wherever yellow area is there, and red is failed area. So we are not seeing any failed areas here, so it is okay mostly. And next you can see the forming zone also. So low strain, wrinkle tendency, and strong wrinkle tendency, and this medium wrinkle tendency, that you can see here with the color tone and plane strains is okay. And these are the tight panels where the red lines are showing. And you can see the safety margins also. You can see the safety margins volume, and mostly these are interpreted within this region, so it is safe. And wherever the minus, you can see, and also the strains you can find out here. And here you can see the displacement also, based on the displacement in the forming displacement magnitude that you can find. So let me move to the next step, where we'll go for the blank definition. You can even find out the spring backs blank definitions. So this is the blank where we are going to estimate the weight and the cost in our next project. So I'll go to the predefined shape, and I'll go for rectangular, and you can go for other shape as well. And let me start with the rectangular one. And here you can see that is the blank size. So this is something 499 by 916 by 897. You can optimize that as well. Show with the blank this, and this is the predefined shape which I gave, so that you can edit as well. And this is my blank. You can export, and you can see the info also, the area perimeter, and without hole this much, so with hole this much. So that differences you can find out because there are holes. And next I'll go to the next and go to the nesting. And here you can see when I will nest it, the blank, you have to specify from the edge what is the distance, and you can define also the blank to coil edge distance. This is the B, and this A is nothing but between your blanks. So I'm just specifying this as 1.5 this, and go for OK. And now if you go for the next, here also you can directly edit the pitch if required, and here also you can edit the coil width, and here you can also assign the constant or rotation. And here you can see the blank die cost, that also you can specify number of production volume, and one upper, two upper mirror or two blanks, that you can cost add per mm. And I'll go to next. And when you go to next, here you can find directly to measure thing, that net weight, gross weight, and part weight. So if you see this gross weight, this is the gross weight, and all after removing the the clearance, whatever will be cutted, so that will be the net weight, and part weight will be this after cutting from the blank what is the part width and the pitch you can see here, and also you can edit the pitch if required. Let us say this 899. There is the width. So let me show you how to edit that also. So just I'll go to next and go to layout editing, and when you go to layout editing, here directly you can see the edit width, and this is 502. I'm just going for 510 or maybe 505 will be enough. You can see the preview 505. Okay, and next this I'll be going for around 902. 902, and you can see the preview. This is the 902, and the 2 and whatever the clearance I gave, that also you can see here. I'll just show you with the enlarged view. This. So based on effectively after updating, you'll get the new values, because before I gave 1.5 something randomly, but after updating this particular sheet size, what is best suitable, that will be updated. And now you can see the part utilization, material utilization, and any total cost per blank, pitch, width which we have updated here, and gross weight and net weight for this particular edited layout, and part weight as well. So then you can directly go to your next process for processing the die type and its operation. And when you directly go for that particular operations, you specify your coordinate system here, where you start your measurement of your tools. Center of gravity I am giving, so this is somewhere here, or you can change that as well, or you can reset it. Go for OK. Next, go for the define process. When you go for define process, here you have to go for forming, trimming, and different hole operations. So that you can see here, all are listed here. So different holes, boundaries, and all forming. So here, if you go to the generate operations, new operations will be updated here, and here you can see some are designated. But let me specify what are different operations and step you have to follow here. When you go to the layout editing and go for editing, maybe 505, which I'm specifying here, is little bit more, so I'm going for 504, which will be enough. And anything else if you want to edit, that you can do. I'll just go to next, and all these operations which I before did, just I have to accept it, save the process. And before saving, you can see here the show part feature. So this is the part feature, the flange, extrusion, darts, embossment, form, and trim lines that will be shown with these colors. So we're all available, so that you can directly find out through this color. And this is basically show geometry evaluation. It will evaluate and show which all different areas are found. Tight radius somewhere, holes in proximity, small holes, and non-standard holes. This green, you can see if you rotate, you can see non-standard holes. So it will show all these areas, multiple issues, red. So there is no red issues, so that you can find out. And here you can see show cam direction for the operations. This is the cam direction for the operations that you can see here. Next you can see the trim and pierce approach angle. So this is the approach angle which is shown, the marginal straight and tipped, and here you can see the fit direction. And next you can see the show the process. So this is the process, and accept it. And next I'll go to the layout editing, and if I was just talking about this, I'll make it 504, and maybe this pitch, if you need to change that also you can do it. So this is enough exactly. I don't want to change this. And now this process is red highlighted, and you can see this by default two operations are only assigned by default. So when you go for right click and go to regenerate, this in fact will be automatically generated and all the step will be shown, and where the trimming and rest of all the process will be allocated properly. And by that you can directly estimate for this particular process what is the overall die width and die cost. And before already I have shown how to see the blank and all width. If you see the summary, number of cams, which type of process, transfer dies, draw, trim, and trim through the cam, that we can see, and overall trim length, die size, minimum stroke per minute 14, and this is the press button rate, number of operations, total die weight, total die cost per part, and part per stroke, and here are the processes. So that all you can find out. And directly the best part here which will be useful is when you go for any changes, that will be updated immediately. If you go for, let us say, this any type of editing, and here you can see the report as well. If you go to this report, directly you can generate the HTML report within your particular folder, and when you generate that, directly you can see your particular report, and where you can find the specification which I have updated, and you can see the engineering follow-up 5.34%, and shear perimeter, you can see the die area, the width, typical areas, thickness, material, that all you will be immediately estimating based on this. And here you see the gross weight and net weight of your blank, that you can see directly. So in this way you can do it. And in some cases, if you want to fill the holes, that also I will show you one scenario how to fill that hole. So in our second series of this project, I will be showing to avoid the holes and do that.